Hello and welcome, Peter here, Piotr Fisner. How are you doing, guys? Hello. So, in today's episode, we've got a part 2 of the PC with various fault. Part 1 was when I've disconnected all the equipment from the computer and I left only the power supply. And I've switched on the cable. And it blown me fuse. So, fuses actually, few. I don't know if that wire is still good. That's least of our worries. But the computer is booked in as a 432 at bookrepair.online.co.uk, and this computer we can confirm that it's a faulty power supply now. Oh, I could hover the. I'll hover it and I'll unpause. So yes, if you've seen the part 1, now it's a part 2. We will focus only on this power supply to see what's wrong, and we will see if it's worth fixing, or maybe just order another one if it's not worth fixing. I mean, you know, like, depend on the price, because if I will say more to the customer than it's another power supply, then customer might say no. Yes, so let's check it and let's see where it will take us. Okay, I'll be unscrewing it, so if you don't want to watch it, you can either leave me a like button this way, or you can just skip the video, up to you. But I wanted to tell you, meanwhile, when I'm doing it, why those power supplies are failing so badly. There is a number of factors why they are failing and why linear power supplies are usually more robust, because the switching power supply unit, yes, PSU, is a switching one. So that's mean it's using PWM signal, pulse width modulation, which is high frequency, like we've got the same in inverters. Yes, it can be 20 kilohertz, it can be even 100 and more kilohertz. So then all the components have to work with such high frequency, and not all the components like to work at high frequencies. And then you see capacitors blown, yes, for instance. Oh, that's quite a bit. I'll show you as well. Yes. So can be overheating, can be many years of work, just many years of work. Can be, I've got power supplies which are switching power supplies, and they lasted only for 1 year because they had usage of many amperes, like charging. I had there is one 12 volts and 50 amperes. If you've got a lot of amperes going through, like these have even more, then what's happening, ooh, I already see one resistor here burned. Then what's happening is, you know, it has to fail. If you would like to have it more robust, yes, you'd have to build on the toroidal transformer. And this could be less efficient than this one, and dear, because toroidal transformers are dear. Plus here we use a lot of voltages. Yes, we use plus 12, minus 12, plus 5, minus 5, 3.3, sometimes minus 3.3. Yes, I don't know like what voltages this one has, but yes, plus 3.3, 18 amperes, plus 5, 18 amperes, plus 12, 36 amperes, minus 12.5 amperes, purple minus 5, SB 2.5 amperes, black COM, so ground, green PS on, so that's for the power on, and power OK, gray one. Yes, so if you will short the green one to the ground, you will get it to power on. We didn't manage it. The first video has blown me fuses, so we couldn't see that. But now I already see some damage here, and I will first clean it up, open it fully, and then we can take it, we can see why, what, and will we fix it or neglect it. Be right back. Okay, I've hoovered it, and if you don't like risking, there is a way to not blow your fuses. You pretty much, what you're doing is on the input side here, you take your meter and you check live and neutral in the diode mode or in the ohms mode. I could do it, but I just thought I'll check it, you know, like I don't know why I've done it. It's just maybe I wanted to blow my fuses, I don't know. But I've done it, yes. So. Yay! Okay, so this one is hoovered, this one has left, and I'll open the rest. Okay guys, so I unscrewed all the screws. I've unsoldered the white wire was at the top here on the PCB, just behind the choke, and black wire was down under. So that's it, that should go out in the theory. Usually they are. Okay, so there's more. Ooh, on the keyboard. Did it? No, it didn't stop recording. And we've got a bit more of hovering, so I'll be right back. I can't even pause the recording. Okay, so let's check my theory, because I said that when I will go into the diode mode, the beep mode, yes, the live and neutral wires should be beeping. So then if you know it, you shouldn't connect to the mains, yes? So that's a lesson. Okay, so it doesn't short here completely, but it's a low ohms. Now it's open loop. I will change them. Okay, so let's change to the ohms readings. Let's see how many ohms do we have. 0.6 mega ohm, and it's still blowing fuse. So you see, in this case I would be wrong, because I would say will be like here 0.000, whereas it wasn't. So not always you can check and say, oh, there's a fault, don't connect it. No, sometimes you just connect it and it's still blowing your fuses. So this time, although I should still test it with my meter, which I didn't, but I wouldn't know it. And there is a faulty component here. I'll make a photo of it so you can see it better. Okay guys, so you can see clearly what have happened here. That resistor, that big resistor here, yes, this one is blown, and this IC is blown as well. So either I'll know which one IC it is, but I can see here that the transistor is, you know, not looking great as well. This resistor is damaged, and in general it's an old ATX power supply. So although we can still save it, don't get me wrong, we don't know what that IC still is. I would have to check it. There is a one resistor R18, which I don't know if I will be able to just find what the resistance is, which we can still figure it out simply by putting two large one and observe how it will work if we've got all the rest of the components, and if it doesn't work we can lower it, yes. Of course we don't have to go for like mega ohms, but we can go for like kilo ohms, yes, and then go down, down, down. And then if we will see that suddenly start to work properly, then it's okay, that's what we need. And as I've got the resistors in stock, so it's not a problem. But we need to know what that IC is. And then all those capacitors are old because they are like a decade old or something. So I would say that if I would charge customer £30 for 1 hour work, and even if I will have all the components, customer will pay probably about 40-45 pounds, because I would like to replace some of those capacitors here. I don't want to just leave it as is. If I see electrolytic capacitors working for a decade, I'd rather replace them, especially those which pulls a lot of amps, yes, because let's face it, it has to work for an extended period of time. So my advice for the customer will be either buy another power supply, at least bronze. If you don't know what bronze is, there's a bronze, silver, gold power ATX2 power supply, and use that one, because that will be new one with a warranty, sometimes even more than a year, 2-3 years. Or if fixed, replace those capacitors, and then I need to check that IC. I've seen that IC in quite a few of them, and I might have this IC in stock, will be used one but still working, and then see what's causing the short, because I don't know if that IC causing the short, and short will be gone after, or maybe there's some more to the short and we need to find that one. So I need to get back to the customer now, ask if customer wants to buy another power supply. If so, I will use my power supply just to power on that computer. Behind me. That computer, and we will make another video about powering it on, if it will power on or not. And if so, if it will be working, we know that we need to either fix power supply or replace the power supply. Once we will do it, we will be able to see how stable that computer is and if all other components are working. Yes, because if we will power it on and will be no post power on self-test, that will be additional cost for the customer, and we need to estimate it. But that's it, I think, for this in this video. We see what's wrong with it. What else wrong? We will know if customer will decide to fix this power supply, but I do believe that customer don't want to fix it. If customer will say no, I will put it on a pile of to-do list, and one day I will just have time to do them all. Yes, well, maybe not day, but few months. I know what I mean. So yeah, I would still fix it. It's partially modular, so it's nice. But hey, customer need to make a decision, not me, so I can't say that it will be this way or another. I'm curious if the rest of the computer is working, yes? Because already we know the power supply is faulty, and it's not really viable option for the customer to fix this power supply. More viable option for the customer is just to replace it. Hopefully there will be another part 3, no more blowing fuses. And we will see if we can help that customer put back the PC to work. Thank you guys for watching. If possible, let's fix them all, and thank you for liking the video. See you in the next one. Bye bye.